Valency, also known as combining power. Atoms are always wanting to achieve noble electron status. This means they seek to have complete outer electron shells. Valency is a term which refers to the number of electrons that an element loses or gains in order to achieve noble status. For example, lithium. Lithium has 3 electrons. In order to achieve noble status, it has 2 options. It can lose 1 electron and have a valency of +1, which means it has 1 more proton than electrons, or it can gain 7 electrons and have a full outer shell here, which means it would have a valency of -7 because it would have 7 more electrons than it would have protons. Another example of this is fluorine. Fluorine is the opposite. Due to its position on the periodic table, it has 7 electrons in its outer shell, which means it could gain 1 electron in the outer shell and have a valency of -1 because it would have 1 more electron than proton, or it could lose 7 electrons for a valency of +7. The positions on the periodic table are fluorine here and lithium is here. Lithium has the valency of +1 or -7, and fluorine is the opposite, having +7 and -1 as its possible valencies. Now, if we were to put the trend of the periodic table on here, which I have prepared earlier, you would see that the valencies have a trend from left to right across the periodic table. Valency can be shown as the trend moves along the periods, with each group consisting of elements of a similar valency. So, this column has a valency of +1 or -7. This is +2 or -6, +3 or -4, 5 and so on until you get to this column. Now, the noble gases already have complete outer shells, so they don't actually want to lose or gain any electrons. So they have a valency of +8 or -0, which is quite convenient for them. Anyway, on recap, which is here, the recap sheet. So, valency refers to the number of electrons that an element loses or gains to achieve noble status. For example, lithium or fluorine. The trend in the periodic table moves along the periods, with each group consisting of elements of a similar valency. And there you have it, valency! Woo.